Hello guys, in this video we'll be seeing the concept of trees and how to build a tree in Java. In this video I'll be covering binary trees. So what is a binary tree? A binary tree is a tree data structure in which each node will have either 0, 1 or 2 children. So I'll be creating a node class which will represent each node in the binary tree. Inside the node class, I am creating a variable data which is the value or data of the node. Then node left, which is a reference to the left child node, and node right, which is a reference to the right child node. Then I am creating or initializing a constructor node of int data. So I'll pass the data as a parameter to the constructor, and inside the constructor I am assigning the value this dot data is equal to data, and then this dot left will be null. Initially the left child is initialized to null and also the right child is assigned to null. Now we'll see how a binary tree will be represented in the memory. As we have seen, a node will have three parts: data, left and right. So this is the left child and this is the right child reference, and the center part will be the data. So this is the example binary tree I have drawn here. So this is how it will be represented in the memory. Now you can understand why we have declared node left and node right. Since the left and right are pointing to another node, the type of the left and right child will be a node, okay? So this binary tree representation in the memory is similar to the binary tree which I am drawing now. Now we will see how to build a tree using an array of nodes. So you must be wondering now why there is a -1 in this array. So -1 indicates a null node here. So if a node does not have a left or a right child, then it is a null node, right? So for that I'm using -1 here, okay? From this array, the first element 1 will be the root. Then one by one the left subtrees will be created first. Now we are encountering a -1 after 4. So -1 means a null node. Since it is a null node and there is no left child for the node 4, we'll go back and then we'll create the right subtree. Now we are again encountering a -1. So we'll move back again. Since the left and right part of the node number 4 were over, we'll move back and create the right subtree for the node 2. So 5 will be the right child of node 2. After 5 we are encountering a -1, which means a null node. So we'll move back and then create the right subtree. Again we are encountering a -1. So there is no left and right child for the node 5. We'll move back and go to node 1. So the next element in the array is 3. That will be the right child of the node 1. After 3 there is a -1. So there is no left child for node 3 and we'll move back. and then create the right subtree for node 3. 6 will be the right child of node 3. Then we'll encounter a -1, move back, again -1, so move back. So always remember that for each node the left subtree will be created first and then we'll create the right subtrees, okay? Finally, this is the binary tree which is being created from this array of nodes. Now we'll see how to code this. This is the code for build tree. First, I'm having a variable index which is initialized to -1. Next, I am having a function build tree in which I am passing the nodes array as a parameter to it, and the return type of this function is node. Why? Because we will be returning the root node of the binary tree. Inside this build tree function, I am incrementing the value of index. So initially it is -1. After incrementing, it will become 0. Next, I am having a if condition which is the base case for recursion. So in trees, we'll mostly use recursion. So you need a basic understanding of recursion before going into the concept of trees. So what is recursion? Calling a function by itself. A base case in recursion is a condition that stops a recursive function from calling itself. It is important because it helps to prevent infinite recursion and ensures it will reach a conclusion instead of going infinitely. So in this base case, I am checking if nodes of index is equal to -1, return null. If we encounter a -1, we'll be returning null, which means we'll go back. As you can see here, if there is a -1, it will return null and we'll backtrack to the previous recursive function call and execute the remaining part. Next, a new node is being created. Node new node is equal to new node of nodes of index. The current value of index is 0. So nodes of index is nodes of 0, which is the first element 1. So that will be created as a new node. Using the constructor we have defined in the node class. So initially the left and right child of node 1 will be null. Now we are going to recursively implement the left and right subtrees. New node.left is equal to build tree of nodes. So again we are calling the build tree function, which is a recursive function. So first the left subtrees will be created and then the right subtrees will be created after the left subtrees have been constructed. At last I am returning the new node, which will be the root of the binary tree. This happens because recursion builds the entire tree and backtracks to the very first function call, returning the topmost node as the root. Now I'll explain how the tree is being created using the code. I'm having the nodes array along with the index for each element. Initially index is -1 and build tree function is called and nodes array is passed to it. Index will be incremented, so it will become 0. Now we are checking the base case if nodes of index is equal to -1. Is nodes of 0 is -1? No. So it won't be executed and the next line new node will be created with nodes of index. So 1 will be created. The current value of index is 0. So nodes of 0 will be 1. 1 will be created as a new node. After that, the next line will be executed. New node.left is equal to build tree of nodes. So the left subtree of node 1 will be created. It will call the build tree function again and the index is incremented to 1. So the next element is 2. We are checking the base case. It is not satisfied. then we are creating the new node which is 2, that is assigned to the left child of 1. Then again the left subtree is created recursively. So the next element is 4. Base case is not satisfied. Then again a new node is created. So 4 will be created and it will be assigned to the left child of node 2. So the recursive function continues until the base case is satisfied. So now we are encountering a -1. So now the base case is satisfied. So it will return null. Since it is -1, there won't be any left child for node 4. So it will return null and we'll go back. And we'll create the right subtree, which is also a recursive function. So it will recursively create the right subtree for node 4. So the index will be incremented and again we are encountering a -1. So since it is -1, the base case is executed and it is returned null, and we'll go back. Since the left and right subtrees are created for node 4, we'll go back to node 2 and we'll create the right subtree for node 2, which is 5. Now for node 5, left subtree is created. The next element is -1. So the base case will be executed and it will return null and we'll go back. Then we'll create the right subtree. So again it is -1. So we'll go back since the base case is executed. For node 5, the left and right subtrees were created. So we'll further go back and we'll reach the node 1. For node 1, we'll create the right subtree. So the next element is 3. So 3 will be the right subtree of node 1. And the next element is -1. So the left subtree will be created first. And since it is -1, the base case is executed and we'll move back. Then for right subtree, we'll have 6 as the right subtree of node 3. Now for node 6, the left subtree will be -1. So the base case is executed and it will return null and we'll go back. And next for right subtree, it is also -1. So we'll move back. Now the entire binary tree is being built and the root of the binary tree 1 will be returned as the new node, since the recursion backtracks to the very first function call.